Let's study 9th standard ICSE Chemistry Chapter 9, Practical Chemistry. This is one of the most important chapters, not only for 9th standard, but even for 10th standard. First, let's understand the tests to identify gases. In your syllabus, you have totally 10 gases. We have 3 neutral gases, water vapor, hydrogen and oxygen, which means that they won't change the color of either litmus paper, blue or red. Then we have acidic gases. There are 6 acidic gases. Water vapor is neutral gas, hydrogen and oxygen as well. But acidic gases are carbon dioxide, sulfur dioxide, chlorine, hydrogen chloride gas, hydrogen sulfide, and nitrogen dioxide. And the last gas is ammonia, which is the only basic gas in our syllabus. Basic gas means it turns moist red litmus blue. Moist is important, this word. But that cannot be a test for a gas. This is just a characteristic. Acidic gases turn moist blue litmus faint red or red, depending on how strong an acidic gas that is. We have to learn the color and odor as well for each of these gases. But again, this can't be a test for the gas. Water vapor, odorless, colorless. Learn these characteristics as well. Now there are 2 tests. That's why I've written or, which means in exam, if you are supposed to write a test, you can write any one of them. But you need to learn all the tests so that you can answer any particular question as well. And you have to learn the equations too. However, do not write the equation in the exam unless they specifically ask for it. So if they simply state, give the test for water vapor, you can simply say it turns white anhydrous copper sulfate blue. That's it, and you'll get 1 mark. If they mention write the equation, then you'll have to write this as well. Even if you are writing an observation for an equation for some chemical reaction, and if you're mentioning that in this reaction water vapor is released or in that reaction hydrogen is released, you need to write the test. We'll discuss this further soon. The other test for water vapor is that it turns blue cobalt chloride paper pink. Now here you can see that copper sulfate, which was white, became blue because of the addition of the water of crystallization. So the amorphous powder, that is, converted into a crystal. That was yet another observation in this equation. Hydrogen. So if hydrogen gas is released, how can you be sure that it is hydrogen gas? I mean, when the gases are released in laboratory experiments, we don't see H2 written on the gas bubbles, right? So we can be sure that it is hydrogen gas by doing a chemical test, which is a burning wooden splinter is extinguished in hydrogen with a pop sound. This pop sound is very characteristic of hydrogen because hydrogen is inflammable, but it does not support combustion. And then there is a note. In various places I have mentioned note, which means that it's a characteristic which we need to learn, but we can't use it as a test. So impure hydrogen burns with a pale blue flame, producing a pop sound. So the difference between this and this is that here the hydrogen was mixed with oxygen, so it will not put off the flame. It will continue to burn, and of course it will produce a pop sound since hydrogen is also present there. In some textbooks, this is also accepted as a test. So in case of hydrogen, it's okay if you write any one of them as a test. But pop sound is true in both the cases. Oxygen. There are 2 tests again. It rekindles a glowing wooden splinter. That is, if a wooden splinter was burning and then it stopped burning, still it would be glowing. But if you put it in an environment of pure oxygen, it will catch a flame once again. The second test is that this gas, when absorbed in colorless alkaline pyrogalol solution, the solution will turn brown, proving that the gas is oxygen. Next, carbon dioxide gas. Colorless and odorless. Note, burning wooden splinter is extinguished in carbon dioxide because it is neither combustible nor does it support combustion. But it's a note. It means it's not a test. It's just some characteristic you need to remember. The test is this. On passage through lime water, it turns lime water milky. And the reaction is that lime water, which is nothing but calcium hydroxide solution, So we should write in brackets aqueous plus carbon dioxide gas gives you a white precipitate of calcium carbonate, which turns the lime water milky. Now there is a note, there is some extra information which you need to know. This milkiness, that is this white precipitate, disappears on passage of excess of carbon dioxide, because this white precipitate reacts with water and carbon dioxide to form calcium bicarbonate, which is soluble, and the milkiness will disappear. Anyway, the test did not end with just saying that it turns lime water milky. That itself will not prove that the gas is carbon dioxide. There is one more step we have to do. We have to pass the gas through acidified potassium permanganate or acidified potassium dichromate. One of them is enough in an exam answer. And it has no effect. There is no change in color. Then only we can be sure it's carbon dioxide. The reason why it's important is because even sulfur dioxide turns lime water milky. That's right. Even here you can see the lime water calcium hydroxide aqueous reacts to form a white precipitate which turns it milky. So just because some gas turns lime water milky does not prove it is carbon dioxide. You have to check it with acidified, the word acidified is important, acidified potassium permanganate or acidified potassium dichromate, because if it is SO2, then the acidified potassium permanganate will turn from pink to clear colorless, or, so one of these two is enough, that is in addition to this sentence of course. It turns acidified potassium dichromate from orange to clear green, whereas if it is CO2, there will be no change in color. That's how we can distinguish between CO2 and SO2 gases chemically. This is a chemical test here. Yeah, you may wonder that if it is odorless, it's CO2, and if it is suffocating odor, it's SO2. But what if you have cold and you don't have a sense of smell on that day? So don't depend on odor. You have to go for a chemical test only. Equations are not important, but please remember this green color is because of a formation of a salt called chromium sulfate. And why this word clear? I'll come to that soon, but you have to write it. Because these tests are given by H2S as well, hydrogen sulfide. But there, it is not a clear colorless or clear green color, because there we have some yellow powder formed as well. There is a note here as well, which is not a part of the test, it's just some extra information. Even here, excess of SO2 would have removed the milkiness of lime water, because soluble salt calcium bisulfite is formed. So let's jump to H2S now, because it is related to this. So, well, H2S does not turn lime water milky, but it does turn acidified potassium permanganate from pink to colorless, but not clear colorless, because here some yellow particles are also formed. As you can see here, sulfur particles are formed. And if you test it with acidified potassium dichromate, then it will turn from orange to green with yellow particles, so not clear green. So now you understand the importance of writing the word clear here, because that's how we can be sure it's SO2 and not H2S, because if you see yellow particles also, it is H2S. By the way, H2S has a rotten egg smell. It is also an acidic gas. But if you are asked to write a test for H2S, I wouldn't recommend either of these two, although it would be correct. The best test is this, a clear-cut test. It turns moist lead acetate paper silvery black. And as you can see, that is because of the formation of lead sulfide. This is lead acetate. So learn this equation. So what kind of a question will be asked in exam? Distinguish between sulfur dioxide and hydrogen sulfide gas, or how would you identify whether the gas is H2S or SO2? So you have to frame the answer like this. Introduce moist lead acetate paper in both the gases. The gas which turns it silvery black is H2S, and the gas which doesn't is SO2. Done. So that's how we distinguish between two gases, and that's how you get the full marks in exam. Let's take another example. There are two gases, hydrogen and oxygen. How will you identify which one is which? Okay. Introduce a glowing wooden splinter in both of them. The gas which rekindles it is called oxygen, and the gas which doesn't rekindle it is hydrogen. Let's take another example. How will you distinguish between water vapor and hydrogen? By the way, both are colorless, so how can you be sure which one is hydrogen, which one is water vapor? Yeah, you may think that we'll let it condense, and if you see a colorless liquid being formed, it is water vapor, but you cannot invent your own tests for exam. You have to stick to these tests. So how about this? Pass the gas or the vapor over blue cobalt chloride paper, or introduce a blue cobalt chloride paper in the gases. The one which turns it pink is water vapor, and the one which doesn't is hydrogen. Or you can use another method. Introduce a burning wooden splinter in both of them. The one which is extinguished with a pop sound is hydrogen, and the one which doesn't is water vapor. So you see, you have to use any one test, either of water vapor or of hydrogen, and you have to show the comparative observations in each, which will help you to distinguish between them. So the answers of this chapter have to be framed in a particular way for which you require a lot of training. That is why for this chapter, the importance of the exercise is incredibly high. And in the notes, we don't have anything for this chapter because this is practical chemistry, which is supposed to be done in the lab. Yet I'm teaching it to you theoretically so that you're able to answer these questions. There are some tricks here which will help you to understand while you're reading it. So after having studied all the tests, you might want to have a look at all these pics. It makes things more interesting. It helps you to remember. So as of now, CO2, as you can see, here they have used a potassium permanganate paper, not the solution, but the observation is similar. Water vapor, you can see the difference here, hydrogen, oxygen, CO2, SO2, H2S. See, lead acid paper is turning silvery black here. So let's go ahead with more gases now. Chlorine. It's a greenish yellow gas. Now in our syllabus we have only one greenish yellow gas, but that doesn't mean you conclude that it is chlorine gas. No, we need a chemical test. Odor, pungent. Yeah, you have to learn this. Even this can be asked in exam. Yes, it turns blue litmus red, and by the way, it gets bleached as well. That means after turning red, with more exposure, the litmus paper loses its color. It becomes white. Anyway, what is a test? This is a note. That means this cannot be a test just because it turns it red and then bleaches it, because even SO2 can do this. That's what is written here, and gets bleached. So I need a chemical test. So here it is. It turns moist starch iodide paper blue-black without leaving a brown residue. So if you have a starch iodide paper, that is starch plus iodine, it will react with chlorine to give you blue-black color. Because the potassium iodide in the starch iodide paper would react with chlorine to give iodine, and iodine always reacts with starch to give you blue-black color. So you need not know the reactions, but this is the observation. And there is no brown residue. Why am I specifying this? Because a similar observation can be seen with NO2 gas. Even here, this NO2 gas will react with potassium iodide to give you violet vapors, and it will leave a brown residue, which is potassium nitrite, by the way. So to distinguish between NO2 and Cl2, you need to remember this one leaves a brown residue and that one doesn't. So just one test for chlorine. There is one more test for chlorine in the concise textbook. That is, if you pass it through silver nitrate solution, a white precipitate is formed. So you may use that also. Although I would avoid it because it is the exact same test which is given by hydrogen chloride gas as well. You can see here, it forms a curdy white precipitate on passage through silver 1 nitrate solution. And by the way, that white precipitate is because of silver chloride being formed. Some extra information. So just a note out here. The precipitate of silver chloride is soluble in ammonium hydroxide but insoluble in dilute nitric acid. There is another test for HCl. It gives dense white fumes when a glass rod dipped in ammonia solution, and when they say ammonia solution, ammonia aqueous, which is same as ammonium hydroxide, NH4OH. It is brought near HCl vapors. So whenever ammonium hydroxide or ammonia solution reacts with HCl, ammonium chloride is formed, which gives you dense white fumes. You can see like a mist formed in the air because ammonium chloride is sublimatory substance. This proves that this gas was hydrogen chloride gas. So this is a very easy gas to be tested for. Remember, whenever there is an or, it means you can write any one of them in exam. If there was an and, that would mean that you have to write the combination of the two, means both the sentences as a test. Finally, we come to nitrogen dioxide, the last acidic gas. We already know one test with potassium iodide. Note that there is no starch involved here, whereas in chlorine there was starch involved. It was potassium iodide plus starch. But there's a better test for nitrogen dioxide, which I prefer instead of using potassium iodide, which is it turns acidified iron 2 sulfate solution brown. Such words like acidified are very important. And usually we acidify solutions by adding a few drops of dilute sulfuric acid. The reaction for this you need not know. You'll study that in detail in 10th standard chemistry. There is a note out here, which means it's just some extra information which you need to study. It's not a part of the test. Nitrogen dioxide, which is a reddish brown gas, but it is not the only reddish brown gas. We have bromine vapors, which are also reddish brown. It has an irritating odor. But just because you are irritated doesn't mean that you are breathing in nitrogen dioxide. Otherwise, you would complain about this gas every time I crack a joke. So, it dissolves in cold water to form both nitrous acid and nitric acid too. That is why it is called a mixed acid anhydride or a diacid anhydride. Anhydride means without water. NO2 gas is without water. With water, it gives you an acid. So from the acid, if you remove all the water, you get the nitrogen dioxide gas. Similarly, what is the anhydride for sulfuric acid? Sulfur trioxide gas. Ammonia. It's the only basic gas. So we've got 3 tests for it. The first one is the easiest. If you have a glass rod and dip it in conch HCl, you forget to write conch and I'll give you a 0, is brought near ammonia gas, you see dense white fumes. Isn't this the exact same as HCl test? In HCl, we brought it near ammonia. And to test ammonia, we bring it near HCl, although here it is conch HCl. And the dense white fumes are because of ammonium chloride, of course. Let me give you another test, which is more complicated. On passage through copper 2 sulfate solution, it will give a blue precipitate, which is copper hydroxide. But on passage of excess ammonia, this blue precipitate will now dissolve. You know why? Because now it will form this complex salt called tetramine copper 2 sulfate in excess. The third test is also very easy. If you pass the gas through Nessler's reagent, then the reagent, that is the chemical solution, will turn from colorless to pale brown. Simple. That means the gas is ammonia. So let me ask you a question. How will you distinguish between ammonia and nitrogen dioxide gas? Okay, how about this? Pass both the gases through Nessler's reagent. The gas which turns it from colorless to pale brown is ammonia, and the gas which doesn't is NO2. Another answer. Pass both the gases through acidified iron 2 sulfate solution. The one which turns it brown is NO2, and the one which doesn't is ammonia. So see, now you know how to frame answers while distinguishing between these gases. The next topic is action of heat on some given substances. In section 2, action of heat, we will study the observations when you heat these 10 substances. Most of them are salts. First, copper carbonate or copper 2 carbonate. It's light green in color. When you heat it, you get copper 2 oxide and carbon dioxide. So if they ask for the reaction, you can write this. Don't forget the heat sign. But if they ask for observations, then no need to write the equation. What are the observations? First, green substance changes to a black powder. The residue is black, copper 2 oxide. And in our syllabus, we have 2 black residues. One is copper 2 oxide and the other is manganese dioxide. Any other observation? Oh yeah, a gas is released. Don't say CO2 is released. How do you know it's CO2? Was it written on the gas being released from the test tube? You have to prove it to be CO2. And that's why we learned all these tests of gases earlier. So a colorless gas is released which turns lime water milky but has no effect on acidified potassium permanganate solution. Or you could have said no effect on acidified potassium dichromate solution. The rest of the things are just characteristics which you need to know, but you know now that there are only 2 tests, 2 observations which you can write for this question in exam. Next, what if zinc carbonate is heated? What are the observations? A residue is left which is yellow when hot and white when cold. By the way, it's an amphoteric oxide. And a colorless gas is released which turns lime water milky but has no effect on acidified potassium permanganate solution. So 2 observations here also. They can even ask a question like this. You've been given 2 salts. Identify which one is zinc carbonate and the other is copper carbonate. Again, you can't just say the one which is light green is copper carbonate and the one which is white is zinc carbonate. No, you can't just rely on that. We need chemical tests to prove it. So, the answer will be like this. Heat both of them. The one which leaves a black residue is copper 2 oxide, and the one which leaves a residue which is yellow when hot and white when cold is zinc carbonate. I repeat, the one which leaves a black residue is copper carbonate, and the one which leaves a yellow when hot and white when cold residue is zinc carbonate. So that's how you can distinguish between the two. Next, washing soda. So it has a decahydrate, that is 10 water of crystallization molecules here. So when you heat it, all the water of crystallization disappears. And from a crystalline substance, it becomes a powdery, that is amorphous substance. And it is anhydrous, that is there is no water left. But the color is still same, white and white. So what is the observation here? Again, there are two observations. One is that crystalline substance turns into an amorphous substance, that is powdery substance. And the second observation is some vapors are released which will turn blue cobalt chloride paper pink, proving that it is water vapor. But that's how we write the observations. You can't just say observation is that water vapor is released. How do you know it's water vapor? You have to write the test. Next, what about copper to sulfate? Well, in the exam, if they specify hydrated copper to sulfate or blue copper to sulfate, then this is the first step. That is, when you heat it, the water of crystallization disappears. So you get a blue crystal turning into a white powder, that is amorphous, and you get some vapors which turn blue cobalt chloride paper pink. But if they just mention heating of copper to sulfate, so no need to mention about this water of crystallization at all. We will directly say that we are left with a black residue and a gas is released which turns lime water milky and changes acidified potassium permanganate from pink to clear colorless, or you could even write that it converts acidified potassium dichromate from orange to clear green. You can also say that a colorless gas is released which rekindles the glowing splinter. So there you go, I just gave you 1, 2, 3, 4, 5 observations. But in exam they will ask you for just 2 observations, so write accordingly. Sometimes even 1 observation is enough for 1 mark. So all of that is mentioned here, learn them well. Next, zinc nitrate. It's white salt. If it's heated, you get a residue which is yellow when hot and white when cold, and you get a reddish brown gas which turns acidified ferrous sulfate solution brown, and a gas is released which rekindles a glowing splinter. So I give you 3 observations here. So what if they give you 2 salts, say zinc nitrate and zinc carbonate, and both are white, and you have to distinguish between them? So how will you frame the answer? Well, heat them. You can't talk about a residue which is yellow when hot and white when cold because it's the same observation in both the cases. So go for something else. So the answer will be like this. The one which releases a reddish brown gas which turns acidified ferrous sulfate solution from green to brown is zinc nitrate. And the one which doesn't give such an observation in the acidified ferrous sulfate solution is zinc carbonate. Or you could go the other way around. You can say the one which on heating gives you a gas which turns lime water milky is zinc carbonate. And the one which gives no such gas turning lime water milky is zinc nitrate. So I'm just using one test and giving a positive test for one and a negative test for the other. If your school teacher insists on giving 2 tests, then follow your school teacher. So she may insist that you say that, okay, the one which gives a gas which turns lime water milky, after heating of course, is zinc carbonate, whereas the one which doesn't is zinc nitrate. And she wants another point saying that the one which gives a reddish brown gas which turns acidified ferrous sulfate solution from green to red, green to brown is zinc nitrate, and the one which doesn't is zinc carbonate. So if she asks for 2 tests, then write 2, but in boards actually 1 test is enough. Next, copper nitrate. Now even that is a blue salt. On heating, it will give a residue which is black in color. It will give a reddish brown gas which will turn acidified ferrous to sulfate solution from green to brown. You know, you're going to practice this so many times that even you will be able to say all these observations very quickly. And as I told you, all of this is there in 10th standard also. It's a very important chapter. Third observation, it gives a colorless gas which rekindles a glowing splinter. And these are the 3 observations for this reaction. A question can be asked that when copper nitrate is heated, name the products formed or name the 2 gases formed. So you will say the 2 gases formed are NO2 and O2. Write names, not formula. That is preferable. And in that case, then you don't have to write a test because they didn't ask for a test. They just asked for the products. So read the question carefully. When you do the exercise, you will get a very nice training of what kind of questions are asked and how to frame it. And my favorite, lead nitrate. It has 4 observations. Observation 1, it leaves a residue which is yellow when hot and yellow when cold. Unlike zinc oxide, which was yellow when hot and white when cold, this is yellow when hot and yellow when cold both. In fact, I would say buff yellow when hot and yellow when cold. Second observation, it gives a reddish brown gas which turns acidified ferrous sulfate solution from green to brown. It gives a gas which rekindles a glowing splinter. And there is a fourth observation here, that's why it's special. It has a decrepitation sound. It produces a crackling sound as it heats up and melts. Next, ammonium chloride. Ammonia and hydrogen chloride gas are produced. So this question can be asked, give an equation in which a solid is heated to give two gases. So you can write this equation. But what are the observations here? The observation here is that a gas is released, ammonia gas. So what is the test for that? Which will turn Nessler's reagent brown. And another gas is released, hydrogen chloride. What is the test for that? When passed through silver nitrate solution, it gives a curdy white precipitate, which is a silver chloride, by the way. Or you can go for another test. A gas is released which gives you dense white fumes when a glass rod dipped in ammonia solution is brought near it. You can refer to all these tests here. You can use any of the tests here. One more observation which is very important in this question is that you will notice that ammonium chloride, when heated, it sublimes on heating, evolving a basic and an acidic gas, which on cooling combines to form ammonium chloride, which condenses on the cooler parts of the test tube. So in short, you can say on heating, it gives some vapors, which condense on the cooler parts to give you white powder. That's it. And no residues left behind. So if they ask you for just one observation, write this one. Iodine. Well, it's a violet solid. When heated, it gives you violet vapors. And what is the test for that? The fumes, that is the vapors, turn starch paper blue or blue-black. That is also a test for starch, by the way, which you would have studied in biology. And no residues left behind, which proves it is iodine. And another important reaction, ammonium dichromate. When heated, the orange substance gives a green residue. There is one observation. Second, it gives some vapors which turn blue cobalt chloride paper pink. That's it. Two observations here. There are some additional points which you may study. For example, there is a flash of light when it decomposes violently. And in concise, they have mentioned greenish grey, but here it's written green. That's okay. Not a big difference. What about this nitrogen? Is there a test for this? Well, not really. But remember, this is a gas which is odorless, colorless. It is not combustible. It does not support combustion. It does not turn lime water milky. So that could prove that it is nitrogen gas. Next topic. So we've got 5 types of salts here. 4 types of salts. Technically just 3. Carbonates, sulfides and sulfites. 3 salts, and we have a metal. How to distinguish between these? What is the observation for these when you add dilute sulfuric acid to them? So earlier we talked about effect of heat on certain substances. Now we'll talk about the effect of dilute sulfuric acid on them. So whenever you take an active metal, that is the metal should be above hydrogen in the activity series, you will notice that a salt is formed. That's fine, soluble salt. But a gas is released which burns with a pop sound when a burning splint is brought near it. Burning splint, not a glowing splint. Glowing splint was for oxygen test. Carbonates. So whenever you have any carbonate or bicarbonate, and you add a dilute acid to it, you will get salt and water, of course. But the interesting test is that a gas is released which turns lime water milky and has no effect on acidified potassium permanganate solution. On the other hand, if it was a sulfite, not sulfate, sulfite, and you add the acid to it, there you will get a gas which has a pungent odor, of course. But the test is that it also turns lime water milky, but it has no effect. It has an effect on acidified potassium permanganate because it turns from pink to clear colorless. So what kind of a question will be asked? They'll give you sodium carbonate and sodium sulfite. Both are white in color. And they will say, identify which is which. So how will you frame the answer? You would say, add dilute sulfuric acid to both. Please don't say that add the salt to the acid. No. Add a few drops of acid to the salt. Both of them will release a gas. The one which releases a gas, colorless gas, which turns lime water milky but has no effect on acidified potassium dichromate solution is sodium carbonate, because you just proved it's CO2 gas. And the one which also turns lime water milky but also changes the color of acidified potassium dichromate solution from orange to clear green is sodium sulfite, because you just proved that it is SO2 gas. So that's the whole use of all these tests. It helps us to understand and identify the substances. What if you were given a salt which is a sulfide, not sulfite, sulfide? Well, add acid to it and you'll get a gas with the rotten egg smell, but that cannot be a test, we'll do a chemical test. Introduce a moist lead acetate paper in this gas, and it will turn silvery black. Instead of paper, you can use a solution also, of course. But then you'll say that let the gas pass through the solution. Visualize the test. Finally, the flame test, because after this, everything is reduced in the syllabus. Congratulations to you. So, if you are given a metal, or a metallic salt rather, you can identify it with the flame test. Remember, sodium salts on heating in a flame will give you golden yellow flame. Potassium salts will give you lilac or violet colored flame. And calcium salts will give you brick red colored flame. Also, some extra information, copper salts give you bluish green flame. These flames are very beautiful, as you can see here. Calcium salt, this platinum wire has some salt on it. So when you introduce it into the flame, it turns brick red, proving that the salt is a calcium salt. The cation is calcium, but what is the anion? We don't know. It could be a sulfate or a carbonate or whatever. For that, we'll have to test it separately. But right now, I'm focusing on the cation of it. If the flame is lilac, it is a potassium salt. If it is a golden yellow flame, it is a sodium salt. Also, look at these pics once again. Ammonium dichromate, greenish residue here, grayish green residue here. Iodine gives you violet vapors which condense to form violet powder again. Ammonium chloride gives you white fumes which condense to give you white powder again. Lead nitrate gives you a residue which is yellow when hot and yellow when cold, and in fact it fuses with the glass here. Copper nitrate leaves behind a black residue. And the gas which is a reddish brown gas, NO2 gas, if you remember, it turns potassium iodide paper brown, you know, the brown residue I was talking about. Zinc nitrate, also same NO2 gas test. There is another NO2 gas test, remember, if you pass it through acidified ferrous sulfate solution, it turns from green to brown, which is what I like to do in these practicals. Here the residue is yellow when hot and white when cold. Here the residue was yellow when hot and yellow when cold. Sorry, not here. Here, lead oxide. Copper sulfate, first of all, if water of crystallization is released, it has its own test. In the end, on strong heating, then copper oxide black residue is left behind. And SO2 gas is also released. Washing soda, it has water of crystallization, which can be proved by the fact that cobalt chloride paper turns from blue to pink. Zinc carbonate leaves behind zinc oxide, so give the test for that. And carbon dioxide test, it turns litmus paper red, but that's not enough. Give a chemical test. Copper carbonate, an action of heat on these. So learn this chapter well, study the exercise very perfectly.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.